Assalamu alaikum everyone. So this right here is May June 2017. Of course, that's variant 2 for the ATP. So let's begin. Question number 1 says the student measures the acceleration of free fall g. He drops the metal ball from a height of 1 meters onto the floor and measures the time t it takes to hit the floor. Cool. Figure 1.1 shows the ball, blah blah blah. He repeats the experiment. Acha nahi. So part A says on figure 1.1 draw the position of the ball at its point of release. So it's supposed to be dropped from a height of 1 meters. Take it. So there's going to be 0 over here. Take it. Yahan pe 0. So there's a 0 centimeter over here. And the ball is going to be above that 0 mark. All right, so that when it falls, so it's going to be exactly at the 100 mark. Okay, so draw the position of the ball at its point of release, so it's going to be above the 0 centimeter mark here. So a lot of people will draw it like this. That would be wrong. This is correct. You need to remember that. The reason being that if, let's say for example, if I drop it from here, so it's already a distance below. So this distance that this ball is going to drop is not going to be exactly 100. And this distance right here that the ball is going to drop, that's going to be exactly 100. All right, so again, this is just something that you need to remember. Calculate the average. Okay, so this right here is 1.2, 1.2 and 2.48. 2.48 and 3.13 if I'm not wrong. So 3.13. So 0.6, 0.6, 0.6, 0.6, 0.6. That's 3. Cool. That's 3. Yeah, 3.13 divided by 5 is going to be 0.6. And then that's going to be 2.6. So if I'm not wrong, we can go with the 6.3. Yep, 0.63. All right, so just why it's not given to more than 2 decimal places, because your data is in 2 decimal places. Take care. So of course, it doesn't make sense to give the average to more than 2 decimal places. So the data is 2 decimal places. All right. So because your data is in 2 decimal places, then your average is going to be at 2 decimal places as well. You cannot be more accurate than the data that you have. So it's better to stay within accuracy. Okay, the acceleration due to free fall is given by the equation. Calculate a value for g. So h is equals to 1, so it's going to be 2 times 1. My bad, sorry. So it's going to be 2 times 1 divided by t average squared. So that's 0.63 squared. And actually it's going to be 0.626 squared. So I'm going to need to use a calculator to do that. So 0.626 times 0.626. That's going to be 391. All right, so then you've got 2 divided by. All right, so we've got 5.1. So, that's weird. Acceleration due to free fall is given by the equation. Okay. Something wrong. Did I find the average wrong? Let's see. All right, take it. I think the average is fine. Everything else is fine. So the value that you're getting is approximately 5.04. So 2 divided by 0.63 and then divided by 0.63 is going to give me 5.04. Cool. So, all right. Um, Again, the reason why that's weird is because we know that acceleration due to gravity is 10. Another student suggests that to obtain a better value of g, the ball should be dropped from a greater height than 1 meters. Explain why the student is correct. So the student would be correct because a longer distance, so the ball will take longer. The ball takes a longer period. Yeah, ball takes longer time to fall. And whenever you increase a certain quantity, you always decrease the amount of human error involved. So reaction errors, various different sort of errors. The larger your quantity, generally speaking, the smaller the errors, specifically human errors in this case. The ball takes a longer time to fall, hence minimizes errors like reaction time. All right. So this is something that you need to remember. ठीक है. Okay, cool. Next question. Student investigates, blah, blah, blah. Draw the symbol for a voltmeter where it should be connected. To measure the potential difference across lamp P. So your voltmeter is going to be like so. So you either draw it above P or below P, doesn't really matter. Figure 2.2 shows the reading on the voltmeter that should be 2.4 volts. She measures PD across lamp Q, records the value of 2.3 together with the brightness. Add your result in A2 to figure 2.3, so that's 2.4 volts. A2 was 2.4, yeah. Done. Figure 2.4 shows the reading of the ammeter in the circuit of 2.1. State the ammeter reading. So that's somewhere in between. All right. So 2, 2, 2, 4, 2, 6, 2, 8, and 3. 3.2 and 3. So this right here is going to be what? That right there is going to be in between 0.3 and 0.32. So your answer must be 0.31. All right. Student states that because lamp Q is not lit, its filament is broken. Explain how the results show that that statement is incorrect. The fact that I'm thinking they were in series, yeah, so they are in series. Now, if let's say, for example, lamp Q was broken, that would break the circuit. And if the circuit is broken, your current cannot flow in the entire circuit. Means, अगर lamp Q जो है उसका, if lamp Q's filament was broken, then lamp P wouldn't light either. All right. So for lamp P to light up, lamp Q must be working just fine. So so we can just write that for lamp P to work, in series, lamp Q's filament should be intact. Now it could not be lighting up for whatever reason. Pretty much the reason seems like that lamp P is getting 2.4 volts and lamp Q is only getting 0.6. So maybe it does not have enough potential difference. So fair enough. It asks the same question in the next part. So just one reason why lamp Q does not glow. Again, like we said, it's not getting enough potential difference. So not enough potential difference for lamp to glow. All right. Ah, man, it's Ramadan. I'm not on caffeine of any sort. So, again, please don't mind the yawning. अच्छा जी, क्वेश्चन नंबर 3 पर आ जाते हैं. Student investigates blah 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 blah. Explain how to carry out the experiment. A diagram is not required. You may draw one if it helps you explain your plan. Generally, drawing is a good idea. So, effect of 3 different insulating materials on cooling of hot water. Sorry, my bad. The following apparatus is available. So, blah 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 blah. All right, supply of hot water is also available. Write a plan. So, the insulators you have, if I'm not wrong, are cardboard, cotton wool, and cloth. All right, so you're gonna measure using a measuring cylinder, and you're gonna put some amount in a glass beaker. You're gonna put a Bosch clamp and a stand. You're gonna use a thermometer to measure the temperature. You're going to use the stopwatch to measure time. Okay, so I'm pretty much gonna use almost everything in this case. Zahir si baat hai, it's going to become very challenging to draw, so I'd rather just explain. So in this case, you can go about it a lot of different ways. One, so again, I'm just explaining what ways you can use. One, time. Oopsie daisy. So you can go with various time slots or time periods. Okay. Okay, I'm gonna measure the temperature every 10 seconds, or maybe 10 seconds is too small. Maybe I'm going to measure temperature every 2 minutes. Yeah, 30 seconds maybe. Again, so it's completely up to you what time you wanna use over here. So I'm gonna measure the temperature every this amount of time, so every 2 minutes, and I'm going to record the temperature at every 2-minute interval. So record temperature at 2-minute intervals. All right, and repeat for various insulators. All right, so you may repeat this for various insulators. That's one way of doing this. Take care. So, what would be another way of doing this? Another way of doing this would be start from same initial temperature for various materials, for various insulating material. All right, so what do I mean by that? What I mean is, let's say, for example, you have your water at 75 degrees every time, and then you maybe measure the time required for the temperature to drop to 40 degrees. All right. So for cardboard, for cotton wool, for cloth, we are all going to measure what? We are going to measure the time required to go from 75 to 40 degrees. So the greater the amount of time, the better the insulator. So in this case, what are we going to say? Measure total time for measured temperature drop. All right, so we know that, okay, this right here is the amount of temperature drop that we are going to measure, and this is the total time required for that particular temperature drop. And again, with respect to the larger the time required, the better the insulator. Same goes over here. The smaller the temperature difference, the greater, the better the insulator. So if you're let's say for example your temperature drops too quickly, so let's say for example every 2 minutes a temperature drop is 10 centimeters for woolen cloth, and for cardboard let's say for example 10 degrees Celsius, and let's say for example for cardboard it's 5 degrees Celsius, probably the other way around, but take it, just taking an example. So in this case woolen cloth would be a the cardboard would be a better insulator, because again it produces a smaller temperature change per unit time or in a particular set interval. ठीक है. So again कार्डबोर्ड इज गोइंग टू बी द बेटर इंसुलेटर, क्योंकि टेम्परेचर ड्रॉप जो है वो कम आ रहा है कार्डबोर्ड के लिए. द टेम्परेचर ड्रॉप इज स्मॉलर. These are one of the two techniques that I'm going to use. जाहिर सी बात है, you can explain it 2 points. Either one is fine. ठीक है, so I'm just gonna move on. Part B, state any quantities that need to be kept constant. So you can go with initial temperature. Maybe write 2. It's 1 point. So of course you're gonna get points on just writing 1, but you may write 2 over here. So initial temperature, you can also go with a constant mass slash volume of water. All right, so the amount of water that you actually have must stay constant as well. Draw a table with headings to show how to display the results. Okay, so you've got time over here. All right. So again, depending on which technique you choose out of the two that I mentioned earlier, let's go with cloth over here. Let's go with, of course, we are measuring temperature drop in degrees Celsius. And then you've got woolen, again temperature drop in degrees Celsius, and then we are going to go with cardboard. Again, that's the temperature drop in degrees Celsius. All right, so let's say from 0 to 2 minutes temperature drop itna hai for the cloth, for the wool, and for the cardboard. From 2 to 4 minutes it's this much. From 4 to 6 minutes it's this much. From 6 to 8 minutes, from 8 to 10 minutes, so on and so forth. And then you're going to, let's say for example, start off with sorry, my bad, not this. You're just going to write the timestamp. So 0, 2, 4, 6, 8, 10, 12, so on and so forth. Maybe take 5 minutes if you want, maybe take less time if the temperature drop is too quick. So then you write the temperature. At 0 it was 75, it was 75. Of course you don't need to write that, you just need to draw the table. I'm just explaining. So after 2 minutes it's going to be, let's say for example, 60 degrees, maybe over here it's 71 degrees, maybe over here it's 68 degrees. So in this case you can see that okay, for a 2-minute interval the cloth produces the largest temperature change, hence it's going to be the worst insulator of the three. The wool produces the smallest temperature change, hence the best insulator of the three, and cardboard is somewhere in between. So that's essentially the idea. Explain how the readings can be used to reach a conclusion. So that's exactly what I was explaining earlier. So the material that produces the smallest temperature change for an interval is the best insulator. Okay, that is going to be the best insulator of all. All right, so that's essentially the idea. Cool. So an object is moved between lamp and a screen. A student investigates how the height, blah, blah, blah. Object is attached to a pin and supported by a cork. As shown, measure the measure and record the height h as shown in 4.2. So again, I'm gonna reduce this to 100%. Okay. So I'm thinking this right here. Usually because they go with integer lengths. So if I'm not wrong, now this cannot be 1. I don't think this is 3 either. So maybe 2 or 2.5. Again, let me just check the marking scheme for this. अच्छा ठीक है, तो मार्किंग स्कीम कह रही है कि दिस मस्ट बी 2 सेंटीमीटर्स। अब जाहिर सी बात है, यहाँ पे मेरे पास आई डोंट हैव एन एक्चुअल कॉपी, अ फिजिकल कॉपी, सो आई कैन नॉट measure this using a scale. Actually, I don't even have a scale at hand right now. तो खैर हो गई. The marking scheme says that this right here should be 2 centimeters. Now, again, it should be 2 exactly centimeters. जब भी, whenever the question asks you to measure distance or an angle, you need to make sure that you're measuring the exact amount. ठीक है, वो exactly होगा. अगर let's say for example if the answer is 2.0, you won't get any points for 2.1 or 1.9. All right, and let's say for example if the angle is 35, you won't get any points for 36 or 34. Okay, usually the angles and the distance are pretty accurate. Screen is placed at a distance d 80 centimeters from blah blah blah. She places object. Okay, measure and record the height h of the shadow. So I'm guessing this right here is slightly larger, the 2.5 hoga. Okay, so the marking scheme says it's 2.3. Okay, so I'm gonna go with that. Okay, so I'm gonna have to figure out a way to measure lengths. So this is at 157%, so I need to find out a scale that goes to 157%. Okay, so I'm gonna do that. Measure and record the length h of shadow shown in 4.3. So the marking scheme says it's 2.3 centimeters. Suggests why it would be difficult to measure accurately the length of the shadow. Usually shadows जो है वो blurred होते हैं, right? मतलब 80 centimeters is long distance. So at 80 centimeters, the shadows would be blurred, your edges are curved. So yeah, so blurred edges of a shadow. And in this case, we can see from the diagram that our shadow has curved edges. So shadow has curved edges, so hence we won't be able to figure out, hence it's not going to be easy to figure out the accurate value. Okay, of course in a diagram it's made such okay, it's not blurred, and even though curved है, it's essentially marked what h is, but usually practically that's not really the case every time. So the h is 2.3, we completed that. Your value, we did that. Plot h on the y-axis and d on the x-axis. Start your axes from the origin. So, okay. Already y-axis has been given. That's cool. X-axis has to be how many units? X-axis has to be 70 up to 70 centimeters. So you've got the only scale that you can use is 10, 20, 30, 40. 50, 60, 70. You cannot go with less, you cannot go with more. Going with more would mean that your scale is just going to be inaccurate. Alright, cool. So let's start taking the values. I'm just gonna take come on. I'm just gonna do that. And put the values over here. I won't have to continuously peek back. All right, so I've got 25 and 6.4. So 25 would be over here. 6.4 must be here. All right, pretty accurate values. Cool, zabardast. 30 and 5.3. So 30 and 5, my bad. So 30 and 5.3. So cool. All right. And then we've got 45 and 3.6. So 45 is going to be here, 45, and 3. 3.6 must be here. Okay, so I'm gonna have to move this. Okay, so 55 and 2.9. So 55 is here, 2.9 goes here, a little less than 3. Then we have 2.60 and 2.7. So 60 and 2.7 would be here. 70 and 2.3. 2.3 would be here. All right, so because again the question initially said curve of best fit, if I'm not wrong, curve of best fit. So okay, so we are just going to draw a curve of best fit like so. इसको थोड़ा सा जो है, I'm pretty sure that I should be able to pass through all the points. Yep, cool. So that should be a good curve of best fit. H40 at 40 centimeters. The 40 के ऊपर my value is exactly 4.1. ठीक है, that's 4.1. Nope. Yep. So we have 4.1 centimeters. H40 is equals to 2h. Calculate age of the object using this equation. So that's going to be 4.1 divided by 2. That's going to be 2.05 centimeters. ठीक है. And calculate the value of, compare the value of h in D2. D2 with value you measured in A. What was the value we measured in A? Was it 2.3 or 2? So it's exactly 2 centimeters and वहाँ पे जो है आपकी value 2.05 है. So yeah, pretty much. State whether your result supports the suggestion and justify. Yes, definitely yes. So value is almost the same. ठीक है जी. Extend your graph to predict the length of age 20. So at 20, 20, 20, 20, 20. So 20 would be, okay, so I'm gonna have to extend it to maybe over here. ठीक है जी, somewhere like so. Okay, 20 के ऊपर जो है वो कहाँ पर आ रहा है? It's gonna be this point right here, which is 8.6. ठीक है, so at 20 it's going to be 8.6 centimeters. The student suggests that the distance d should not be less than 10. Give one reason why this is a sensible suggestion. So your curve is going to be beyond the scope of this scale right here. So if you want to do that, you wouldn't use this particular scale, because the question gave you this particular scale, right? So we won't be able to draw that. Here, of course, we are also going to say that the shadow take maybe the screen's big enough, maybe 9 centimeters. I don't see why that's gonna be a big problem. Maybe आप कह सकते हो कि yeah, the shadow is gonna be too big for the screen, but I'm not exactly sure that would be correct or wrong. ज़ाहिर सी बात है, I haven't been able to measure the screen. I cannot measure the screen. So I'd still go with the fact कि भाई you cannot measure a value that's less than 10 centimeters, less than 20 maybe, with this particular scale right here. 20 से भी कम अगर आप जाते हैं तो it's gonna extrapolate way over here. All right, so you won't be able to measure less than 20, let alone 10. So scale not suitable लिख देते हैं. So scale is not suitable. All right. या हम लिख देते हैं extrapolated value goes outside the graph, goes outside the graph. ठीक है जी. D was kept constant throughout the investigation state. Why? जाहिर सी बात है, अगर D चेंज करेंगे तो for the same capital H, as in for the same object, your shadow lengths are going to be different. So to make sure that you have accurate readings, तो जाहिर सी बात है आपको जो है वो D जो है वो आप चेंज नहीं कर सकते. All right, so D cannot be changed because it will change the length of the shadow. All right. Yeah, so that's it for this paper. That's May, June 2017, if I'm not wrong. Yeah, May, June 2017 4-2. Inshallah, kids, I'll see you in the next one, which would be October, November 17. All right, take care. Tata, bye bye, Allah Hafiz. Bars out.